Now, in the next question, you see that denominators of the fractions are not just the simple constants, rather these include some variables also, like this, it has got this variable b and so on. So, how we need to solve them? Let's see. The basic procedure is the same. Like in the last question one, we discussed three cases. Number one was when the two numbers were totally different. As you could see in part A, 3 and 5 were the numbers which had only just one common in between them. Second case was only one common factor. Second case was like this, multiples of each other. As 9 is a multiple of 3, so you just multiplied the first fraction with some factor so that their denominators would equalize. So you didn't multiply the second fraction by some number like this. And the third case was like this, some common factor, not just the multiple, but any factor that could be taken as common. So in that case, what we did, we took their LCM of 8 and 12. The LCM of 8 and 12 was 24, and we solved it like this. We just made each denominator 24. So multiplying 8 by 3 and this fraction by 2. That made their denominators the same. 8 3s are 24 and 12 2s are 24. So this is to be applied on this next question as well. Now you see that in the first part, x and x square are there in the denominator. So this is the case that is going to be applied, because x square is a multiple of x, because it can be written as x times x. So in the second fraction, x is already there. So I just need to multiply this with another x dot x, and to equalize it, I need to multiply it in the numerator as well. So what's its benefit? We have got the common denominators, 2 by x squared plus 5x times x squared. Since their denominators are the same now, so we can make them as a single fraction having x squared in the denominator, 2 plus 5x. So there is no further simplification. That's why this is going to be the answer. There is a common mistake that mostly students make. What do? They just cancel this x with x square. So that is a wrong practice, because you cannot cancel them like this. The reason being, this 5x is first of all being simplified or added in the numerator 2 as well. So first of all, you need to make it as a single numerator, then you can cancel them out. So this cancellation cannot take place, so this is going to be your answer. Okay. Same goes with part B. You see that 6x and 3x are multiples. So you just need to multiply the second fraction by 2 only. That will make their denominator same, 5 by 6x. No change in the first fraction, but in the second fraction, this is 2 divided by 6x. Now you see that their denominators are the same. So making them as a single denominator, 6x, and in the numerator, this is 5 minus 2. Now, since we can simplify these numbers, this is just the subtraction of these numbers. So we can simplify it. So that would give me 5 minus 2, 3 by 6x. Now, even in this case, we can further simplify them. 3 ones are 3, 3 twos are 6. So simplification is possible. So we need to give the answer in the most simplified form. So 1 by 2 times x, or half x, half and times 1 by x. So this is going to be your final answer, like this. Okay. Now we are doing some other part. Let it be part J, for example. Now we need to see that the denominators are not the same. So we need to take their LCM, W and WX square. These are the denominators. So taking their LCM, W ones are, and then 1 times x squared. And then x are x, and then another x. So the LCM is going to be WX squared. So in the second fraction, the denominator is WX square already. So to make the first fraction to have its denominator to be WX squared, you can see that we just need to multiply the first fraction by x squared. So now their denominators are the same. The first one is having x squared times w, and the second one is having the same x squared times w. So writing their denominators once, wx squared. In the numerator of the first, we are having x squared times x cube, which would be x5, minus this 2 would be the only term written from the second fraction. So x5 minus 2 divided by wx square. Since there is no further simplification possible, so this is going to be the final answer. Uh, in the same way, let me solve part K as well. For part K, you see uh, the denominators are ab square and b cube. Taking their LCM, ab square times b cube. First of all, dividing them by a, this would be 1 times b square times b square, b cube. Then dividing them by b, this is 1 times just 1b times b square. Then dividing them by b once again, this is 1 times 1b, and again third times b. This is 1 times 1. So the LCM is b times b, b square times b, b cube times a. So the LCM is a times b cubed. Now this is the denominator that we should be having. So 2 by ab square is already there, minus 3 by b cube is already there. To make their denominators same, to have this LCM, a b cube, I just need to multiply this by 1b. So that's why the denominator would become ab cube. And in the case of the second fraction, I just need to multiply it with a. Now the denominator is ab cube, and this is also ab cube. Denominators are the same, writing them as a single fraction, ab cube, And in the numerator, this is 2b minus 3a. And that's it. No further simplification of b term and a term because these are unlike terms, the different terms. So no more simplification. That means that is going to be the answer. Okay, let me do another part like uh, part L as well. We again see that their denominators are different. So having the LCM of 5 and x, 5 ones are and x would be the same. Then x ones are. So 5x is the LCM. So I just need to multiply the first fraction by x and the second one with 5. This is x square y by 5x minus 5 by 5x. Now you see the denominators are the same. So we can write them as a single denominator 5x x square y minus 5. No more simplification is possible. So that's why this is going to be the answer.